The world of cryptocurrency is abuzz with whispers of a new technology that could reshape the landscape of quantum computing. Bitcoin, the pioneering cryptocurrency, relies on complex mathematical problems to secure its transactions. Could quantum computers, with their immense processing power, crack these codes and threaten the very foundation of Bitcoin? The answer, like the technology itself, is complex and multifaceted. It requires delving into the heart of Bitcoin's security and the capabilities and limitations of these futuristic machines. The potential of quantum computers to disrupt established industries is undeniable. Their ability to tackle problems previously considered insurmountable has sparked excitement and fear in equal measure. For Bitcoin, the question is not just theoretical, it's about the future of a decentralized financial system that has captured the imagination of millions. Understanding this potential impact requires a grasp of how Bitcoin works, particularly its reliance on the SHA-256 cryptographic hash function. This function acts as the guardian of Bitcoin security, ensuring the integrity of transactions and the overall stability of the network. Our journey begins by exploring this crucial element of Bitcoin's architecture. Let's unravel the mysteries of quantum computing and their implications for the future of Bitcoin. The journey promises to be both fascinating and enlightening. At the heart of Bitcoin security lies a cryptographic hash function known as SHA-256. Imagine a digital fingerprint unique to every piece of information it encounters. That's essentially what SHA-256 does. It takes any input, whether a single word or an entire book, and transforms it into a fixed-length string of 256 bits. This string is unique to the input, meaning even a tiny change in the original data will result in a completely different hash. This property is crucial for Bitcoin mining, the process by which new Bitcoins are created and transactions are added to the blockchain. Miners compete to solve complex mathematical problems, essentially finding a specific input that, when hashed with SHA-256, produces a result that meets certain criteria. This process is computationally intensive, requiring significant processing power and energy. The first miner to find a valid solution gets to add the next block of transactions to the blockchain and is rewarded with newly minted Bitcoins. The SHA-256 hash function ensures the integrity of this process. Any attempt to tamper with a transaction, even changing a single character, would result in a different hash, invalidating the entire block. SHA-256, with its remarkable properties, has long been considered a formidable barrier against attacks. However, the advent of quantum computing has introduced a new element into the equation. To understand why we need to explore the strange and fascinating world of quantum mechanics. Quantum computers operate on principles fundamentally different from the classical computers we use every day. Instead of bits, which can be either a 0 or a 1, quantum computers use qubits. Qubits leverage the strangeness of quantum mechanics, allowing them to exist in a superposition, a state where they are both 0 and 1 simultaneously. This unique property allows quantum computers to perform computations in parallel, exploring multiple possibilities at once. Imagine searching through a maze. A classical computer would have to try each path one by one until it found the exit. A quantum computer, on the other hand, could explore all paths simultaneously, finding the solution much faster. This parallel processing power is what makes quantum computers potentially well-suited for breaking certain types of encryption, including the SHA-256 algorithm that underpins Bitcoin's security. However, before we delve into the potential threat, it's important to understand that not all quantum algorithms are created equal. One algorithm, in particular, has garnered significant attention for its potential impact on Bitcoin mining. Grover's algorithm. Let's examine how this algorithm works and what it could mean for the future of cryptocurrency.